Okay, so what I want to do today is give an introduction to Chapter 2 and go through sections 2.1 and 2.2. And what we're doing in this chapter is introducing limits, but I think it's probably a good idea before we start studying limits to have a little bit of context for what we're doing, because limits are very technical and it's not really obvious why we care about them, and I want to make that clear before we get ourselves deep into the details of how limits work. So I'm going to start with a little bit of a history of calculus. Okay. So I think most of you have probably heard of Sir Isaac Newton. Okay. Um, Sir Isaac Newton wasn't a mathematician, he was a physicist. I mean, he was also a mathematician, but like his main job was a physicist. And the calculus that he invented was to support his physics. However, there's a little bit of controversy over this. So, we'll sort of dive into this real briefly. Newton, it turns out, was kind of a shy guy and had a little bit of an embarrassment earlier in his career, which made him hesitant to publish things that weren't definitely right, that weren't crisp and clear and worked thoroughly through. Being a physicist, he was, I think, probably a little bit more anxious about publishing, purely about math. So at one point, in trying to make some of his physics stuff works, he ends up um, developing some math further. Now, there's a lot of buildup to this, and um, his mentor Barrow was also a great mathematician that kind of set things up, but didn't quite take the leap into what we call calculus now. Um, but Newton came through with a lot of discoveries, and he sort of hid them away in the appendix of one of his works on physics. Okay, so Newton starts working on physics, at some place in the timeline. And I don't have the dates in front of me, but there's some dispute to some of the dates anyway. Okay, many, many years later, Newton publishes. Okay, now, a guy that probably few of you have heard of is William Gottfried Leibniz, and he was a German mathematician and philosopher, and probably mainly a philosopher, but his work in mathematics is also exceptional. And he started coming up with some ideas, and he published what we call calculus. He did it before Newton did. And that created some controversy on both sides. So Leibniz publishes calculus, then some of Newton's friends say, hey, this is stuff that we've seen in your work. You've been doing this for years. You need to publish it. So then Newton publishes it. And then people on Leibniz's side say, hey, wait a minute. You can't publish that as original work. That's already been done. That's just Leibniz's work. And then they're like, no, Newton started working on this earlier. And it gets more controversial because somewhere back in here, Leibniz was in Paris at the same time that Newton was having correspondence with somebody in Paris about his calculus work. So maybe Leibniz could have seen some. There's all sorts of controversy, and the fights went on for a long time. Anyway, I think in retrospect, mathematicians give them both credit for independently coming up with it because a lot of their ideas are different enough that they don't look copied. It just so happens that we had a lot of the right setup ahead of time. Okay, now, in both of their approaches to calculus, they did something that logically doesn't hold up really, really well. Okay, we've had to kind of clean things up logically. Newton invented something called an infinitesimal, a number so small that no matter what you multiply it by, it's still a really tiny number. Leibniz came up with this idea of a monad, an idea or a number so tiny that it can't be broken up any further. So they're very similar sort of things, but logically, when you're constructing mathematics, they create a lot of new problems that it's hard to have a consistent mathematics, including them. They sort of create more problems than they solve. In retrospect, what we've done is we've said, well, let's get to the same idea, but we'll use a different logical tool. And what we're going to do is explain their ideas with something called a limit. Okay, so we're going to clean up their ideas. Okay, all of this, though, is really to deal with the problem of infinity. Infinity is a difficult concept to work around, and limits give us a very clean way to handle infinity. These infinitesimals and monads, they can work, but they're real complicated, and they create a lot of new problems, and so we're just going to talk about limits. So this is the motivation for limits. It's kind of the basis for all of the calculus stuff. Now remember that calculus wasn't invented as like, hey, here's a cool math idea because of math. Newton did this to explain how motion works, optics. He used it in all of his physics stuff to kind of describe how our world works. And Newton's physics is like the real basic physics. We're not even talking about the real strange stuff like quantum theory. So obviously it has its roots in being very practical, and especially in physics applications. So we're going to see a lot of that as we go through the semester.